All right, this video is for learning target 7. It's a continuation of the 5 and 6. We actually learned all 3 of these targets, 5, 6, and 7, in the same day. But learning target 7 is writing an explicit and recursive formula for geometric sequences. We did something similar to this in learning target 4, where we wrote explicit, recursive, and formulas for arithmetic sequences. It's easy to teach, but it's also easy to forget if you don't practice it or keep it on a note card and remind yourself, because it's a pretty quick thing to learn. But if it doesn't go to long-term memory, it might not be there. So you got to make sure you do what you need to learn this. It's going to seem like it doesn't have a whole lot of application at first, but it has a whole lot of application, and we'll see more of it in learning target 10 and 11, and it's just going to come up in a lot more places. But anyways, to write an explicit or recursive formula, all you need for a geometric sequence is the A1 and the R. Much like in learning target 4, when you only needed the A1 and the D. For explicit, we'll take this example first. Its A1 is 3, the R is 2, and again, go back to learning target 5 if you have any questions about that. But the explicit formula will just be A sub n equals first term 3 times R, which is 2, to the n minus 1. There's going to be a temptation to maybe multiply that 3 times 2 and make 6, but then you'd be multiplying before taking care of an exponent, and that would violate the order of operations. So there's really nothing you can do algebraically here to simplify this. So that's your explicit rule. What's it good for? Again, there's several other uses, but one is if I ask you to find the 25th term of this sequence, you just take 3 times 2 to the 25 minus 1. You've already got a formula there that's specific for that pattern. All right, so now the recursive. The recursive follows this formula. Any term, A sub n, can be found by its previous term being multiplied by the R. So A sub n equals A sub n minus 1 times 2. And you have to define your starting term, A sub 1 equals 3. Now that's an okay answer. I'll take that. It's fine. But I prefer that you write it as A sub n equals, that's a variable, A sub n minus 1 times a number 2. And if I asked you to write x times 2, you'd probably write it as 2x. So I would prefer this as 2 times A sub n minus 1, and again define A sub 1 as 3. But I'll take either one. All right, so just one more quick example. Again, it's easy to teach this, but it's quick. It's easy to forget it too, so do what you need to. For writing an explicit, A sub n, you need A sub 1 and you need R. So A sub n in this problem is 10, and the R, remember, you can always find it by taking a term like 5 and dividing it by the term in front of it. 5 divided by 10, so the R is 1/2. So your explicit rule, A sub n equals first term 10 times your R 1/2 raised to the exponent n minus 1. And that's coming from the explicit formula. Recursive, A sub n equals A sub n minus 1 times R, because the reoccurring pattern is times R over and over again, times 1/2. I'd prefer it to be written this way, A sub n equals 1/2 times A sub n minus 1. You also could write it as A sub n equals A sub n minus 1 divided by 2. I mean, that'd be fine too. But don't forget to define A sub 1, your first term is 10. Now the recursive pattern, I'll just talk a little bit about it. It's more useful, say, if I asked you to find the 5th term, which would happen to be the next term. So to find the 5th term, you would just multiply by 1/2. Take the previous term, 5 over 4, and multiply it by 1/2 and get 5 over 8. And that's where the recursive pattern is more helpful. But that's learning target 7 notes.